This is our newest version of the Coop Concierge. If you were to buy this separately, not installed by me, you would get it in this shape with no holes for the wires. And so if you needed to put the holes in the wires, this video will show you how. First thing you need to do is take off the front panel by removing these 4 screws. Carefully pulling out the band cord on the side. Now you can see the main power supply, which we also need to remove, and you do that by removing the 4 screws on the rear, but keeping your hand up on the power supply so it doesn't drop down. Not losing the screws. Alright, now that we remove the 4 screws, the power supply comes out. So we just have our standard box with none of the ports drilled yet, which I'll show you how to mark and drill. A quick look at the main power supply unit. We have our 110 coming in, ground, neutral, and power. We have the lines going to the solar panel, and our standard is a shade of red is always positive, and then the other is negative or ground. So that goes to the solar panel. This goes to the battery. Again, red is positive. This drives the motor on the door itself, and this is the door sensor, so that the interior light will go on and off with the opening and closing of the door. And last but not least is this power supply to the LED light bar. So if you were to wire this, you don't necessarily have to use the 110 because it will run totally off the solar panel and the battery, but you definitely will have to wire the motor. You don't have to have a door sensor, and you can use the lamp if you choose to use the lamp. So that is the main unit. Periodically we do a software upgrade, which would require upgrading the CPU. The CPU is actually on the front panel, so if you look at the front panel as it came off, we'll get to the CPU. Just taking off these 4 screws. Now that we have the front panel off, you can see the actual CPU, and here we have written that it's most recently updated 4/4/2013 with version 7D, which version 7D is our current version. So all the capabilities with version 7D, I'll quickly go through them. Obviously it opens and closes the doors based off the solar lookup table, so you enter in your lat and long and it opens and closes the doors based off an offset from sunrise and sunset for that particular day. When closing, it has the sense down capability, which on the way down it's sensing the load on the motor, and if that load exceeds a threshold, it believes it's hitting obstruction and will reopen, and then it will close again. 10 minutes later, it'll open again, called the tardy chicken capability, which is to allow any tardy chickens to get into the coop. It also, when closing from tardy chicken, it will sense any kind of obstruction and open on the first closing. On the second closing, it drives closed, assuming you definitely want that door closed. Some of the other new capabilities added to the Coop Concierge for version 7D is low power indicator, which flashes the interior light if the power gets below a certain voltage, letting you know that either the sun hasn't been out long enough, or you haven't had it plugged in, or if you had snow covering the solar panel or something to that effect. And they're all the new upgrades for version 7D. For my standard installation, I need to put 6 holes into this junction box. On the top, I typically put my LED light, my power source, my solar panel, extra outlet, which is where I run my 110 out so that I can have an outlet on the opposite side of the door, the power to the door itself, and then on the bottom I put the line to the battery. If you were going to mount this away from the door, you would have to put a 7th hole, which would be for the door proximity sensor line. I typically put this so close to the door that the proximity sensor actually gets mounted inside the box, and the secondary magnet gets mounted on the door, and it can sense it through the wall of the junction box. First thing you need to do when drilling the holes is measuring and putting marks where you're going to drill the holes. One thing to keep in mind is you don't want your holes in front of the tabs for affixing this box to the wall. I've done this many times when I try and use the drill to put in the screws and the lines are in the way. It makes you very unhappy. So for the top side, I make it 1.5 inches deep, and I put a mark at 2 inches and 4 inches. There are the 2 top ones. Again, this is going to be the LED light, and this one's going to be the power supply. On the side of the box, I put 3 marks, and this is at 1.5 inches, 3 inch, and 4.5. Again, 1.5 inches back from the top. And on the bottom, this is for the battery. I put this one at, this should be 4.5. I actually marked it 4.25, so I need to make a new mark, 4.5. That one is for the battery. Again, on this side we have, top one goes to the solar panel, the middle one is the extra outlet, and the bottom one is actually the door itself. Then we'll go and drill these. Alright, so we're just about to drill the holes into the box, and we use a 7/8 inch paddle bit. Believe it or not, paddle bits work the best on this kind of material. I've used every other kind of bit and they all gum up or melt the plastic and make a nasty hole, but for this, the 7/8 inch one does the best job. And on the drill press makes it all that much easier. So we have our marks, and alright, easy enough. We'll do another one and show you how it's done. There you go. And I'll finish the rest off. Alright, now that we have all our holes drilled for where our wires are going to pass out of the junction box, again, to go through them, LED light, power supply, solar panel, extra outlet, door, drive, and battery. Once we have that done, we're going to install our wire connectors. Actually, they're, I forget what they're called, some sort of wire grab thingamajigger. I'll think of a new name. Alright, so we're installing the remaining wire connectors, and this would be included if you had bought a separate Coop Concierge. I would include the wire connectors you need. Again, it's important that they're mounted 1.5 inches down so they don't obstruct the motherboard when it gets put on, and it's also important that they're drilled not directly in front of the mounting ears. I've done that, it's not fun. Oh, I needed a 6th one. Alright, we'll put that in. Alright, so here we have a junction box with all the connectors, strain relief core connectors they're actually called. Believe it or not, these things cost me like $2.50, so it starts to add up. Now again, this has 6 core connectors. You could possibly need a 7th if you were going to mount the proximity sensor somewhere away from this control junction box. Now that all the core connectors are in, all the holes are drilled, we can reassemble, which means gently putting the master power unit back in. Gently, gently. It's a little more difficult now that there's a lot of the obstructions, but we can do it. It does fit. Okay, and turn it over, line up the screw holes, and put back in the screws. That's probably good. Okay, so again, now we have the power supply unit remounted, and it can look a little overwhelming because you have so many wires, but each wire just needs to be dealt with on its own. Obviously this is going to be driving the door again, so that's going to go out this hole. Actually, we're going to have a wire come in here and wire nut it. This unit is actually going to go to the battery, so that one actually comes out through this hole. This goes to the solar panel, so it's going to come out this hole. This is the power supply, which is going to come out this hole, and this one for me is an internal, this one goes to the LED light, and the last but not least is the internal sensor for the proximity sensor for the door. Alright, again, for illustration purposes, because you'd make all these connections within the junction box, I've routed each set of wires through their corresponding hole. This one powers the LED light. This would be AC power coming in. This is going to the solar panel. This one will eventually have an outlet coming out of it, but I don't have that yet. This drives the door, yellow, blue. This goes to the battery, red, gray. And then this will be internal, which will get mounted to the side, which will be the proximity sensor, unless you're doing that externally. And this is the wire band that actually gets connected to the front panel. Let me show you that real quick, what the front panel connection is. So if you look, you'll see the wire band connector right there, and this gently gets inserted in, which will be hard to video, but I think you'll get the idea. Alright, does that make sense? Alright, now we'll run all our wires. Again, we have a fully wired power supply. This is the connector to the LED light bar. If you were to put the LED light bar further away, you could run a cord, a patch cord between the junction box and this connector, but the LED light actually connects right to this. A weather-tight seal is formed with a threaded nut that goes on here. This is going to the power supply, which you don't necessarily need, but it's very good to have 110 for the dead of winter when we might not be getting enough sun to run the unit. Here we have going to the solar panel, the additional outlet, the actual door itself, and then down to the battery. And then we also have the internal proximity sensor, which the other part of the proximity sensor gets mounted to the door, and this is the wire band that goes to the actual CPU front panel. And of course, I don't want to forget, you always want to have a fuse on the positive leg of your battery in case any kind of short circuits were to occur. Which you can see here, opens up and there's a typical car fuse in there. In this particular case, it's a 4 amp fuse we use. Alright, so I want to show how you actually use a strain relief and how they work. So in here is a rubber gasket that there's a tapered area there. Then when this gets tightened, it squeezes that gasket around the wire. So the strain release very loose. This wire has already been stripped. Push it through the strain relief. I like to get to the point where the insulation is just showing on the inside of the box, and then you tighten the strain relief, and now that cord is attached. For all my cords, I actually buy a 50-foot indoor-outdoor extension cord. and I cut off the plug end, the outlet end, to make it my extra outlet. I use the plug in for my power supply, and then I use all that's left to run to the battery, to power the door, to go up to the solar panel, and for the lights I actually have a connector for that, but I use the entire 50 feet. Wire nutting is also very easy. You want to make sure your two wires are lined up to the same distance, stripped to the same amount. Take the wire nut, twist it on. Again, I'll show you that with the two greens. Turning clockwise to tighten the wire nut, and then the two whites. Again, lining them up, pinching with your two fingers. Believe it or not, this takes a while to learn how to do. It's very easy for me because I've done a lot of them. And there you go, wire nutted. So that's all you need to do. Again, this is my standard configuration. I went through all the steps of dismantling the unit, marking and drilling the holes, putting in the strain relief core connectors, and then showing you how you would then attach the wires. But this represents how I would orient it for my standard coop. If I had a door that was on the opposite side of the coop, I would have to shift all this to the other side. So each individual coop design, coop construction may require a different orientation of all these strain relief connectors.